Um, what I want to focus on is generally how we assess the cost of climate change and why I think that the current assessments of the cost of climate change are underestimating the costs. And Belinda will focus on a specific case study for New Zealand and one specific channel through which climate change will have an impact. Now, if we think of, I'm an economist, and I apologize for that, but that is going to be my focus, the economic costs of climate change. So there are other costs which I'm not going to be speaking about much. There are two basic ways in which economists try to assess the costs of climate change. One is through statistical estimates based on the past. So looking at the past in terms of temperatures and in terms of economic activity and assessing from that what would be the cost when the temperature changes. That's a bit like looking at the rear view mirror to know where you're heading, which is a fine strategy if you are thinking about the next bend in the road, maybe. But if you are thinking about a road that is 500 kilometers away, it's probably not the best way to understand what would be the road conditions, right? And in that sense, I think that method of assessing the cost of climate change, which is quite popular, and there are a lot of papers that have done that, is not very good if we're thinking about what will happen 20 years or 30 years or 40 years from now. It might be pretty good to understand what will happen next year because of climate change. So that's one approach. The other, and maybe the more popular and more prevalent approach is using integrated assessment models. So the integrated assessment models, as the name imply, they integrate two kinds of models. They integrate a model of the economy and a model of the climate. Okay? So the model of the climate scientists do that, which, I'm not a climate scientist, so I don't know how they do that, but they have a lot of models of the climate. They acknowledge that all of them are wrong, but they average them out, hoping that the average somehow makes sense. That's the modeling of the climate. And then we have models of the economy, which are probably even worse than the models of the climate, because here we are talking about modeling people rather than modeling atoms, and people change, and their behavior changes. But anyway, we have models of the climate, a model of the climate, a model of the economy, and then we have these two arrows which basically integrate the two, right? So we know that the economy affects the climate, and we know that the climate affects the economy, and that's what we're trying to assess, but we need to make a lot of assumptions about the ways in which the economy affects the climate and the way in which the climate affects the economy. So if we look about the results from these integrated assessment models, this looks at sort of probably the 7 most popular integrated assessment models that are used globally to assess the cost of climate change. And here you have just a description of how much damage they think will climate change cause to the global economy as a function of what the temperature change will be. Now, if you're at all familiar with the discussions about climate change, you know that, for example, in the Paris Agreement in 2015, the discussion was mostly whether we should aim for a 2% increase over pre-industrial times, 2%, 2 degrees, not 2%, 2 degrees above industrial, pre-industrial period, or maybe 1.5, and that was, the main discussion. Everybody agreed that above that would be too risky. But if you look at the integrated assessment models, if you look at what they predict will be the cost for a 2 degrees increase in temperatures, most of them think that it's not very large. Okay? And yet they do think that climate change will have a big impact if we get to the 5-6 degrees above pre-industrial times. But most non-economists think that 5-6 degrees above pre-industrial times will be catastrophic, right? So the question is, where is the mismatch coming from those two models? I'm going to first go back a bit and give you one example of where I think the integrated assessment models are wrong. And this looks at extreme weather events. Okay? The integrated assessment models all try to understand the impact of the average change in the climate. But I think all of you know that one way in which the climate change is having an impact on us is through the impact of changing the probability of extreme weather events. So climate change is causing extreme weather events. Now, it's not strictly causing them, because extreme weather events happened before climate change. We've always had floods and hurricanes and tropical cyclones and droughts, but it's changing the probability. In the same way that smoking causes cancer, lung cancer, right? You can get lung cancer if you don't smoke, and you can't smoke all your life and never get lung cancer, but we know that, that smoking changes the probability of lung cancer, of getting lung cancer. In the same way, climate change is changing the probability of being flooded, of experiencing a drought, and so on. And in the last 10 years, we've had a lot of advance in the science in assessing what is the change in that probability of these extreme weather events. I'm going to focus on one example, briefly, and that's Hurricane Harvey that occurred in 2017 in Houston, in Texas. And, you know, a very stable genius observed that it was one of the wettest ever seen. That hurricane was one of the wettest ever seen from the standpoint of water, which I'm not sure what he means, but he meant. But luckily, he has no Twitter account anymore, so we don't know. In any case, that is, you know, this was acutely observed. That was what was unique about Hurricane Harvey. It was the fact that it dumped a lot of water on Houston and resulted in extensive flooding in the city of Houston. So what we do in a paper that we published last year, we look at what is the change in the probability of what was the change in the probability of Hurricane Harvey occurring because of climate change. The change of causality here is pretty simple. It's simple enough that I can understand it. The water temperature in the Gulf was higher than usual because of climate change. Because the water in the Gulf of Mexico was higher, that meant that the hurricane had more moisture in it, and because of that, it dumped more water on Houston, right? And the destruction that resulted from that hurricane was not from the wind, was from the water, was from the flooding. So what we know that, and there are some range of estimates, but roughly speaking, about the event became more likely by between 70 to 80% because of climate change. Okay, so the fraction of attributable risk of Hurricane Harvey was pretty high. Okay, without climate change, it's very likely that Hurricane Harvey would have dumped a lot less water on Houston. Now we can combine that with the cost that we know that Hurricane Harvey had on the city of Houston, which was, again, there are different estimates, but around roughly $100 billion. That's billion, right? So $100 billion, and then we basically multiply the two, and we conclude that the anthropogenic impact of Hurricane Harvey was $67 billion. So what do we mean by anthropogenic? That is caused by us because of climate change. Okay? So without us and climate change, the cost of Hurricane Harvey would have been a lot less, because it would have been weaker. Now, if you think of back to those integrated assessment models, we are now roughly one degree above pre-industrial times. So what are they predicting in terms of the current cost of climate change? Well, nothing, pretty much, right? But I just argued that Hurricane Harvey had $67 billion of damages. So what we do is we take one of those models, actually the most prominent one, which is DICE. DICE is a model that was developed by William Nordhaus, and he largely won the Nobel Prize in economics for that model. And if you look at the DICE model and what the DICE model says, Well, you need to do some crunching of numbers, but basically the DICE implies that in 2017, the total cost of climate change in the United States in 2017 was $18 billion, $18.8 billion. Okay? That's the total cost of climate change in the US, and that includes everything. It includes the 3 hurricanes that occurred in the US in 2017, because there were, other than Harvey, there was also Irma and Maria. It also includes the fires in California. It includes all these other droughts and all these other impacts of climate change that happened in 2017. Now, you don't need to be a mathematician to know that 67 is bigger than 18.8. Okay? So just Hurricane Harvey in Houston is the cost of the anthropogenic cost of Hurricane Harvey is much bigger than what the IAM is predicting for the whole of the United States for the whole of that year. Okay? That leads one to suspect that maybe the IAM, the integrated assessment model, at least this one, is wrong. Okay? Now, why might they be wrong? There are potentially many answers, and probably all of them are true to some extent. First of all, the models, as all models are useless. This is, I'm sort of misquoting a quote about planning, right? People say that planning is useless, but plans are useless, but planning is everything. In the same sense, that's true for modeling as well. Models are useless, but the modeling is important because that allows us to focus on what kind of channels of causality might matter. Okay, so models modeling is essential, but what these models spit out might conceivably not be very reliable. There are cascading costs that we ignore in those models, and you can easily think of cascading costs, and the most sort of obvious explanation is, the most obvious example would be the drought in the Middle East that led to the Arab Spring, that led to the flows of immigrants from the Middle East to Europe and then to Brexit. So you can pretty easily tie up a fairly convincing causal chain from climate change to Brexit. That's an example of a cascading cost. There are a lot of non-monetized costs. I'm aware that I need to finish, right? I still have time. And there are other issues, like all these models assume linearities in the cost. So, for example, about extinctions, we assume that losing one pair of moas is the same as losing the last pair of breeding moas. And that's clearly not true in many instances. So we do think that, for example, extinctions are worse. There's issues around discount rates, which is incredibly boring and incredibly important. Discount rates, typically economists assume a discount rate of 5%, arguing that that's about the real rate of interest, but the real rate of interest hasn't been 5% for at least a decade. But even if you use a 2% discount rate in the IAMs, you end up with scenarios in which the future more than 30 or 40 years from now doesn't matter that much. And that's, whether we should take that ethical position is questionable, but that's very important. Some people argue, like Nick Stern, Lord Nick Stern, that you should use a very, very small discount rate, maybe 0.1%. And that changes the cost of climate change tremendously. The conventional integrated assessment models typically use a discount rate of about 2%. But that changes. For example, just to give you an example, the Trump administration, when it came to power, changed the discount rate used in the official integrated assessment models that the US uses to calculate the social cost of carbon. And they changed it to 5%, which meant that the cost of carbon that they estimated went down from about $35 a ton to $2 a ton. And then they argued, then therefore we shouldn't do any mitigation because the cost of, there was another difference that they have made, but I'm not going to focus on that. What should be the social cost of carbon is something we derive from these IAMs, and that's a very important number because that determines what should be the price of carbon that we use in those emission trading schemes that we use globally. So for example, anybody knows the current carbon price here? Yeah, so it's about, if we look at in US dollars, because most of the international literature is in US dollars, it's about 30 US dollars. Most of the people who have looked at that think that the cost should be at least twice as big. Some people argue it should be 10 times as big. But clearly 30 US dollar per ton is less than the social cost of carbon, even in these integrated assessment models. There's other issues around population ethics, but I'm gonna cut that, and I'll be happy to address those in the Q&A.
So I'm Belinda Storey. I have my own research organisation, and I'm a somewhat delinquent PhD student as well. So here at Vic. The way that I came to thinking about pricing risk in climate was wanting to see how property prices were changing. And I started looking at the coast more and more as I would visit my mum and dad's beach house, and thinking about what was likely to happen to property prices. And what I realised is that property values were likely they were effectively changing from permanent ownership rights to temporary use rights. That there was a time limit being set on coastal property. Now, once I started looking at this, I realised that it wasn't just coastal property, it's any location that has escalating hazards. So sometimes when you start looking at something, I developed a framework, looked at what the possible areas of influence on how long you could stay would be there. Initially, I thought it was about how long the land was there, so I looked at information about coastal engineering and what sea level rise was going to be at the end of the century and the like. But when I started modelling this, I soon realised that there were a number of other retreats that were going to occur that would impact the value of the property well before then. But sometimes when you start wanting to answer a big question, you then find that there's a significant piece that's missing. So you get together a team to look at that, try and answer that piece. So what I realised is that insurance was going to have a significant impact on property values, and I needed to be able to bring together a team to look at insurance retreat. So started to have an idea looking at thresholds that were applying internationally. And we heard from the insurance industry that they were very unlikely to continue to insure a property for flooding once the probability got to 1 in 25 years. So what that means is, 1 in 25 years means you've got about a 4% probability of the event occurring each year. Now we talk about annual exceedance probability, so we convert that return period, so a 1 in 25 or a 1 in 100, to the annual probability. So an event that might happen 1 in 100 years has a 1% probability of happening each year. And that's a really key point to think about when you're thinking about climate change, is that those events are becoming more frequent. And just because you had a 1 in 100 year storm happen last year, doesn't mean it's going to be 100 years before the next one happens. So with a 1 in 100 year event, it has about a 1% AEP, annual exceedance probability. You can use that as a baseline that a number of insurers use in terms of mapping out floodplains, for example. And what we heard from the insurance industry is that once an event gets to about a 4% probability, so about a 1 in 25 year event, they would not continue to offer insurance. Now, you won't see that in any annual report of any insurer anywhere in the world, but we have been able to validate that by looking at where insurance has remained available, where there's been a shift. To be even more conservative, we took a higher percentage, so we took a 5% AEP, so about a 1 in 20 year event, and we used that as our threshold. But what we know is that in some locations, even when you get to only 2% probability every year, you can start to have restrictions placed on your insurance availability. Interestingly, when we did the literature review, we found that in the UK, the probability that threshold that private insurers were using was only 1.3%. So private insurers stopped offering insurance in the UK once the probability got to a 1 in 75 year event. So people who were in a 1 in 100 year floodplain, with just a small increase in that probability from 1% to 1.3, were finding that they weren't able to get insurance. I'm going to talk here a little bit about how that change in probability works with climate change. Now, I'm using a normal standard distribution here. Many hazards use this, some of them don't, but it is the one that's most familiar to people, so I use this to kind of explain the concepts. So, and when we talk about climate change, there's some parts of climate change that are easier to predict in terms of the science. The scientists have the most confidence about temperature change. They have reasonable confidence about sea level rise if we ignore the ice sheets. They've got less confidence, but they're right at the edge of the science in terms of precipitation. And no one in the world is able to model how storm surges are changing in terms of climate change. That's something that is beyond the reach of science at the moment, but obviously intense efforts looking at that. So what you have here is, there we go. So this bit down here is an example of an insurable event. So an insurer isn't going to insure an event that happens all the time. They're going to insure the rare events. And so under climate change, the entire distribution is shifting. How much it's shifting by is something that climate scientists are looking at. And we have at least one of them in the room here today at the back with Luke, wanting to get an understanding of how these distributions are shifting. But what we find is that when the distribution shifts, you would have heard Ilan talk about that all of the, most of the modelling to date has been done on the averages of climate change. So it says, where's this new average going to be? Now the new average happened fairly frequently in the old distribution. So in this example, it happened about once every 6 years. So the new average will feel quite familiar. But what happens is that at the extremes, you get these really big shifts in the probabilities of events. Now insurers are going to want to keep their threshold. As that distribution shifts, they will shift with it. And so people who might previously have got insurance because they were within this probability are unlikely to find that they're still getting insurance once it shifts this far. And you might say, well, how big of a shift is that? Is that something that's going to happen at the end of the century? What we found is that with just a really small amount of sea level rise, you can get 5 times increase in the probability of an extreme event. So if you're in a 1% probability, you can go to a 5% probability in Wellington with 10 centimetres of sea level rise. So just a really small amount of sea level rise is enough to shift that. Now climate change is also changing the shape of these distributions as well. And so it's shifting even further. So we have received funding from the National Science Challenge, the Deep South National Science Challenge, and we got together a team and we worked with them on wanting to understand what those thresholds would be. Now we looked just at sea level rise. We didn't look at extra storminess, so just sea level rise. So we used analysis that was undertaken using extreme event analysis, and what that does, generalised extreme value, sorry, and what that does is calculates how the probabilities change with just a small amount of sea level rise. So what you see here, these are all intersecting at the 1% AEP. So what it's saying is how much sea level rise does it take to start moving up this here? And what you'll see is these different shaped curves in Auckland and Wellington, and Dunedin and Christchurch. And one of the key insights that we got from this is that because we have such low variability in our storm surges in New Zealand, we have hugged our coasts very tightly. And it means that it only takes a very small amount of sea level rise for us to start overtopping our barriers. The difference between Auckland and Wellington is almost all to do with tidal range. So I'll talk you through a little bit there. So bear with me here. Just want to help you get through. It took me a while. So if you've got a big tidal range, so say you've got a tidal range of about 4 metres, and I've split this into basically the tides into quarters. So if you get a storm surge come in at low tide, doesn't matter. It'll get absorbed within the existing tidal range. If a storm surge comes in at high tide or even 3/4 tide, then there's a real chance it'll overtop. But if you've got a small tidal range, like Wellington, then again, if you get a storm surge happen at low tide, it's okay. But if you get a storm surge happen even at mid-tide, it'll overtop. So what that means is, here you've only got a 25% chance of a storm surge of that size overtopping. But here, you've got a 50% chance of it overtopping. So what that means is, with exactly the same amount of sea level rise across all of the New Zealand coastline, Wellington will experience a greater shift in the probability of overtopping sooner than Auckland will. They're not far behind, but they are there. So what we looked at is, what would the insurance premiums be in the absence of retreat? And we define insurance retreat as the situation where a person who has previously had insurance, or a property who has previously had insurance, finds that they're declined or they no longer receive a renewal. What we found is that when we talk with people, most people assume that if they don't engage in insurance fraud and they continue to pay the insurance premiums on time, then they will have an ongoing relationship with their insurance provider and they will have insurance at least for the length of time that they own that asset. But insurance premiums are renewed every year. Every year, the insurer decides whether to renew that and whether to continue with you. And if the probability is shifting and is reaching that threshold, they will simply not offer. They won't tell you why, because there's no incentive for them to tell you why. They'll simply decline it. Partial retreat happens when there is a reduction in the range of policy that is available to you. So we know that in Flockton Basin, for example, when the earthquake happened in Flockton Basin, effectively formed a bowl that collected a whole bunch of rainwater. What you had there was you had $10,000 excesses applied to flood insurance. That is transferring quite a lot of the risk back to the insurer. That was one way that the insurer manages the cost of insurance, by putting in these very high excesses. Interestingly, what we found is that there were locations in these floodplains that should be paying much higher premiums today than they are. And we anticipate that that's probably because there's cross-subsidisation. So there's cross-subsidisation between risky locations and less risky locations to be able to have a more even difference between the policies. But if you increase your probability of an event from a 1% to a 5%, your insurance premiums, you should expect them to go up by 5 times. So we then mapped those against those thresholds, and what we found is that it takes just a very small amount of sea level rise in Wellington for people to start to experience that partial retreat. And by the time you've got to 12 centimetres, you're very unlikely to continue to be able to get insurance, if you're currently in a 1% ADP zone. We then mapped that against timing, about when we would, given the amount of sea level rise we can expect in the next 20 years, next 30 years. There's not much difference between the representative concentration pathways because sea level rise is baked in. It's quite a long lag period, so there's not a lot of difference there. So what we found is that Wellington and Christchurch are the ones that are first likely to experience retreat. But even in Auckland and Dunedin, which have larger tidal ranges, they will also should be experiencing full retreat. Now, again, this is just with sea level rise. This isn't any increase in storminess. So this isn't any stronger extratropical cyclones, for example, that Ilan was talking about. When I talk about this, people often say, well, okay, private insurers are pulling out, what can we do? One thing they say is, can we harden our coasts? And I won't talk about that today. But the other thing they say is, well, can EQC step in? And I would strongly encourage you to think twice about having EQC step in. In the States, there are a number of international examples of this, but the most famous one is the National Flood Insurance Program. It came about following Hurricane Betsy in 1965, where there was a significant damage, people weren't insured, private insurers said we weren't going to do it, and so that there was a public SIS scheme set up. What that does, it was designed to be grandparented, but instead of actually grandparenting those people in those current locations, what it did, it was subsidise a massive wave of coastal development in the 70s onwards. And to give you a very concrete example, Ilan and I are very much motivated. We undertake this analysis because we want to be able to identify ways to reduce the full risk, not just transfer it to someone else, on the basis that we are reducing the risk to life. So it may not seem like it when we're looking at numbers all the time, but we undertake that work because we're wanting to reduce those individuals that are kept in harm's way. And to give you an example, the location that had some of the biggest damage in Hurricane Betsy in 1965 was Louisiana, was New Orleans, and it was the Ninth Ward, which some of you are probably familiar with from news reports of Hurricane Katrina's large fatalities that happened in the Ninth Ward when the levees failed. So subsidising insurance keeps people in harmful locations. This is a brief summary of some of the papers that Ilan and I have published recently, but we are very keen to hear your questions. We have microphones here.
Just a procedural question, please.
Do you mind waiting for the mic, because
we're recording
it, and without the mic.
But that's what I want to know. Will that be online?
Yes, everything will be online.
I had a question about the insurance. First of all, thank you. That's really interesting. To what extent do you know are insurers commissioning their own modelling versus relying on publicly available modelling data?
Depends. You're best to ask Tim Grafton of that for the Insurance Council. But what we observe is that reinsurers hire climate scientists, but local insurers will tend to, retail insurers, so the people that you tend to buy will tend to rely on public funded research.
Not internally. So the insurers operating in New Zealand typically buy risk modeling from several providers like RMS, and I think there's a bunch of others that have stepped in recently, but RMS used to be the only one here in New Zealand. So it used to be the case that all the insurers were buying the same model, which is worrying in and of itself, but that's a different conversation. Questions?
Oh, we've got a mic coming through.
Kia ora, thank you for your presentation. I'm interested in your engagement with the Climate Change Commission, and any thoughts that you had on their take on the impacts of climate change on the New Zealand economy.
Whenever research is completed, we undertake active briefings to share that research, and so all of our research would be available to them, and we do have conversations with them, and we collaborate with at least two of the council commissioners on research themselves. But in terms of making an assessment, that's not something I'd do today.
And most of the Climate Change Commission work up to now has been mostly about mitigation rather than impact. So mitigation meaning, what would be the kind of paths to reduce greenhouse gas emissions and so on. And that's not our focus.
Thank you for your presentation. I'd like to know, in climate change issue, would there be any property owner that are located in a coastal area being rejected for their insurance application? And also in developing, normally the coastal area gives a view and the lifestyle. Would climate change issue inhibit developer to develop in coastal area and go to inland?
So on the first question, we believe that people are definitely being declined insurance on the coast, but we don't know where. We can undertake analysis that estimates where it is because the insurers do not provide that information. The other piece is I know that some real estate agents say, check if you've got insurance, but all that is you're checking, have you got insurance today? Have you got insurance for the next year? And then in terms of developers, what we see from international research is that the changing risk is not currently incorporated in decisions. So the things that you talk about the view and the like, people value that so much that they tend to ignore the risk. Yeah.
Thank you.
Yeah, I had a question. Thank you very much. Why do insurers retreat rather than stay but adjust their premiums? What's the mechanism that makes retreat the right commercial strategy?
We anticipate that that's most likely because of reputational risk. And if I give you a concrete example, when the Edgecombe flood banks failed, there was a pensioner who found that his insurance premium went up to $5,000 a year. And as a pensioner, he called Radio New Zealand and he says, I'm a pensioner, that's $100 a week. I can't afford insurance policy. After that, the insurance company said, I'm sorry, that was a mistake. We'll change your insurance premium. But that will probably only be temporary. So what they find is that people have a sense of outrage when if your insurance premiums are increased by 5 times, even if it's justified on a break-even analysis, people have a strong reaction to it. And from an insurer's perspective, you're better to simply quietly decline. That wouldn't be the case in commercial.
Maybe adding one more aspect here. While the change is gradual, the insurance is changing their risk models only periodically, maybe every 10 years. So that means that they can't slowly ramp up their premiums, but rather when they adjust their model, they realize, okay, we need to increase the premium by 50%. And then you get this outrage and reputational risk that they don't want to incur. And it's easier for them to say, okay, we're sorry, we just can't provide insurance.
Yeah, I've just got a question. Sorry, I'm not an economist. Can you explain to me the term discount rates?
Yes. So discount rate is basically how do you view the future versus the present? Okay, and the standard assumption in economics is that for every future year we value it a little bit less. Okay, that's what we call the pure discount rate. On top of that, there's other aspects of that because of uncertainty and so on. But basically, the idea is that in our assessment of the future, we place less importance of the future than the present. And there's plenty of research that shows that people actually do that. Okay, but the extent of the discount of the future is sort of the disagreement here. Who has a
We've got
mic?
you.
We don't
Where's
know
the
where
mic?
the mics are. Yes.
Thank you. I'm interested in your comments about the cost of climate change when we're talking about non-tangible facets such as in the Pacific when we're talking about identity, loss of homes and loss of place, loss of heritage?
Economists are not very good at thinking about that or measuring that, for that matter. And that, to some extent, so this refers both to my comment about non-tangible assets or non-quantifiable assets, and also non-linearities. Because we think differently about, for example, an island where people need to move a little bit inland versus an island like Tuvalu or Kiribati, which will actually disappear with sea level rise. And then there will be a culture that will disappear because of that, when everybody will have to go to a diaspora of some sort. So all of these things are very difficult to quantify. Okay? That doesn't mean that they're not important, right? A lot of the things that are most important in life are unquantifiable, and a lot of the things we quantify are not terribly important. But you know, that's the constraint we work with.
In our, the Whakahura program is a major program looking at extreme events, and within that we have a stream of work that is specifically looking at, led by Sean Aotearoa, which is looking at the definition of damage from a Te Ao Māori perspective, to try and broaden that, because we tend to think about deaths in dollars when we think about disasters, but broadening that about what is a wider definition of damage that is caused by these extreme events.
Thank you for your presentations. I just wanted to circle back to the question that was asked at the front there, and I apologise if this is a double up. I couldn't quite hear the whole question. But I'm interested not only in the developer's perspective or what their thoughts are, which we hear is not many, about what's going on around that space. Apologies to any developers in the room. But what about the territorial authorities and their responsibilities in this space as well? If they know there's likely to be harm, either directly through risk to life, but secondarily well-being because of impacts of financial catastrophe that result from this. So when does the law start to actually come in from a TA perspective to help manage that?
So from when I started looking at this, I interviewed people about the national policy statement, which came in 2010, and what I heard uniformly is that it is ignored, that it is almost impossible for a local government to hold that. Now, one of the principles says that you should take into account climate change hazards over the next 100 years, but any time that a local government tries to do that, they end up in court. And so we strongly encourage that councils be required to provide information on risk, and that the relative role that they have compared to developers who can be well resourced in terms of legal approach is rebalanced. So we know that there is development continuing, and people who are doing their darndest to slow down development find that they are very immediately find themselves in court. I think it's helpful maybe to talk about the Kapiti case here, because that's the most, it sent a chilling effect through local government. And so Ilan did a piece of research to say, well, what actually happened here? And it turns out...
So the history of the Kapiti Coast, if you're not familiar, the Kapiti Coast Council put some warning in on their limbs of houses there that some houses will become uninhabitable in the future, and they had several scenarios: 50 years managed, 50 years unmanaged, and so on. And they put this on the limbs, saying for these specific houses, this land is not going to exist in 100 years or in 50 years. And they were taken to court and had to remove those warnings from the limbs. So we also looked. So that's a chilling effect for local councils, who then say, okay, Kapiti Council, which is not a very wealthy big council, had to spend a lot of money defending its position in court and then lost and had to remove those warnings. So that's one aspect of it. We also looked at the prices of property as a result of that, putting it on the limb and then removing it from the limb. Surprisingly, there wasn't much impact. So prices went down by maybe 2 to 3% because of the warning on the limbs for those properties where warning was placed. And then it went back up once the warning was removed from the limb. So, you know, the local authorities are in a very difficult position here. The government is aware of that, and we are talking about the review of the Resource Management Act, right? So hopefully, any future act that will emerge from that will deal with these problems. One hopes.
Question for the economist. John Maynard Keynes would probably embrace a disaster like an earthquake, simply because of all the rebuilding effort afterwards. So, in terms of what you're doing here, how do you define cost? I see you put on a slide where you say Nordhaus and damage, but damage is not necessarily cost. How do you define cost? Simply because one person's cost is another man's or person's benefit.
Yeah, this is a very long answer to that. What is the...
You're back to yours.
So first of all, your comment about John Maynard Keynes, that's what we call the broken windows fallacy, right? The broken windows fallacy is we can increase GDP by breaking a window, because then we need to hire somebody to fix the window. So that's been known. The economist who came up with the broken windows fallacy was Frederick Bastiat in the 19th century. This is not a new idea, that you can't measure just GDP and say everything is fine because we broken some windows. So we are not under any illusion that this is the right answer. So what they're looking at, where is my...
Which one?
The one at the appendix.
Appendix, okay, right. Hang on.
This one, yes, thank you. So when you have a disaster, you have damage. So when you have a disaster, you have damages. So that's assets that get destroyed. And that can be mortality or morbidity, and it can be displacement or asset damages, assets that get destroyed. And then that leads to indirect losses, which means decline in economic activity because of the assets that were damaged. There might be a stimulus effect because then you're spending money on rebuilding those asset base. And then eventually, or in the long term, you might have lost well-being because of the assets that were damaged. Yes, you spend money on the reconstruction, but that money could have been spent elsewhere. So it could have been, putting in parks instead of building the road that was destroyed, right? And therefore, there is a loss to well-being in the long term because of that damage. That's the short answer to your question. But it is a complicated issue, right? There's no one easy number that we can always use without attaching a lot of caveats and nuances about what that number means. The number that I quote for Hurricane Harvey is the damage. Okay? The number that the integrated assessment models talk about is the indirect losses to GDP. Okay, so it's a flow variable versus the stock variable that for Harvey. Okay.
Yeah, just following on from the second to last question. From what you know of the insurance companies, how much notice do they take on about local policies applying to the coast? For example, local authorities that might plan to build seawalls rather than retreat. I mean, and related to that, how open have the insurance companies been with you in discussing these issues? I get the impression that they're not being terribly transparent towards their customers, but have you been able to have direct discussions with the companies?
Yes, we do have direct discussions, but we don't ever get any data. So we have a collaborative, we test ideas and we absolutely brief them before my research came out, but they don't provide data. There are some jurisdictions that do require insurance companies to provide insurance retreat information to their regulator, and we would strongly encourage that. Doesn't necessarily have to come to researchers, but the regulator, the people who are making policy decisions, should at least be able to see that themselves. Would what?
TCFD, what they do that here?
TCFD will encourage insurers to provide some reporting, but they won't. There is a possibility that it will escalate insurance retreat, because they will need to have more transparency about cross-subsidisation. But yes, that is something that we are looking at in terms of how the impact of TCFD will have on insurance and insurance on the economy. Did I answer your full question?
Well, the first part about what I said, do they take note or do they take account of locals?
So insurance companies will absolutely want to see about whether there's defences put in place. An insurance company has every incentive to encourage a local government to spend public money on defences that allows them to remain in place for the next year. The cost of that defence might have to be spread over 50 years, but there's always an incentive for the insurance company to encourage that defence to be put in place, because they maintain their market. At the back? No? Oh, sorry, you go.
Kia ora. I wonder if you have any insights into how insurance companies approach cross-subsidisation of premiums, say in a town or suburb?
Can I?
Yeah.
So it is puzzling that you observe cross-subsidization, because in principle, why would a private insurer embark on any cross-subsidization? I think there's two issues here. One is the reputational issues that we already discussed. So they perceive, they're worried that it will be perceived as unfair if they charge radically different amounts from people who have the same value property. So they're worried about that. Therefore, even though their models maybe suggest that the difference should be this high, they decrease the difference because of the reputational concern. The other issue is that their modeling is not very sophisticated. So they don't really have very good quantification of the risk, not because they're ignorant or anything. It's just it's expensive to do sophisticated modeling, and they maybe rightly decide that it's not worthwhile to really spend a lot of resources on very particular modeling for specific properties, because the cost doesn't match the kind of benefit that they can get by differentiating the premiums. Yeah? Now, because the cost is changing and declining, the cost of modeling is declining, that implies that we will move more and more towards this discrimination. It's not discrimination, is not maybe the right word, because there's a negative connotation to that, but differentiation in terms of insurance premiums. And we're seeing that.
Hi. I've got two quick questions, hopefully quick. The first one is a practical one. As I understand it, for the changing in uninsurability, you're basically drawing a line on a map, which is the 1% AEP. There's a thing there, and then basically people live between that 1% line and the ocean.
That's because that's the maps we've got. We would very much like to have more granularity there.
Do you have any rough idea as to the extent to which the distribution of assets between that 1% line and the ocean differs city to city? And then the second question is this sort of...
In what parameter, in what dimension?
I don't know, stuff, like the houses, like it must go from 1% to 2% risk to 3% risk, and then you're in the ocean. Along that gradient, is there much difference city to city?
It's overwhelmed by the amenity value, so it's overwhelmed by sea views. There's very little discount in property values at the moment because of climate change. The studies that have been done suggest that even in the centre of Miami, or near the coast of Miami, that there's a discount of 4%, which is not likely to be around in 50 years.
Sorry, I was talking about the annual exceedance probabilities. But.
Yeah.
Yep, that's what we mean.
We don't know the...
Right.
We don't have mapping like that, so we don't really know how within the differences across cities of the gradient from the 1% upward towards the ocean. We don't know if the gradient is different across.
So NIWA's endeavour will have, that's led by Sandine, will include better information on that in terms of floodplains.
I got one quick second question, is that this all kind of makes sense when you're talking about, okay, you got a 4% chance in a given year that an event happens, and for the purpose of flooding, it kind of makes sense that conceptually maybe that's the inundation of your house, a place. What is the equivalent that we can talk about for other types of extremes?
So we rely on damage functions. So particular types of events will have different impacts. So in this, for example, when we were looking at flooding, if you're less than a certain height of flooding and you've got a wooden floor, you probably get 30% of the value of your house will be damaged. So that's a damage function that tells you. Whereas in the case of a fire, if you get a fire in your house, you've pretty much got 100% damage. So we have information on that is looking at past events, which are called damage functions.
And you have, similarly, you can have damage functions for wind damage and for other types of hazards. So in principle, you can do the same kind of analysis for other types of hazards if you think that your damage functions are good enough.
So I'm wondering how big events have to be for you to reasonably take the kind of approach that you took with Harvey to look at the fraction of return risk. Could we look, for example, at the hurricane that hit the Bay of Plenty in 2017 and look at something like that, or is that just too small?
So in principle, you can calculate the fraction of attributable risk to any kind of extreme event. In some cases, even for big hurricanes, the fraction of attributable risk might be very small or might be very large. In Harvey, it was very large, which is why we chose that event. But equally, it could be very, very small. In principle, you can calculate that, but that Luke might be better placed to respond to that. But in principle, you can calculate the change in the probability for any type of event. The problem is it's complicated to do, so typically it's undertaken for fairly big events. And it started being done with the heat waves about 15 years ago in Europe, especially the one I think in 2003 was a very, very large heat wave that caused a lot of mortality.
So this paper here includes information on attribution events in New Zealand. And so one of our colleagues has led work that looked at, for example, flooding in Northland and the flooding that flooded South Dunedin. And what they found that the flooding in South Dunedin had only a 5% attribution, whereas the flooding in Northland had much more. So they can be done.
I think we need to finish.
Happy to answer questions.
So happy to we'll stay here and answer any other questions if anyone have any. Thank you very much for coming, and I hope to see you again in some future events. Cheers.